Welcome to this video. This video is in continuation to my previous video on the topic of coordinate geometry for grade 10. Let's recapitulate what we all did as for coordinate geometry for grade 10 is concerned. As for the first video is concerned, we discussed distance formula and applied distance formula to textual sums. Then in the second video, we took up the topic of section formula and applied section formula to different sums as far as the textbook is concerned. Now, as far as this video is concerned, we'll be taking up the subtopic of area formula. This area formula is applied to area of a triangle as well as area of a quadrilateral, be it any quadrilateral. Now, before going into the formula, let's see what all formulae you have learned since grade 7 and grade 6, different formulae that we have been using for finding area of a triangle. Now, the main formula that you have used for finding area of a triangle is half of base into height. Area of a triangle is 1/2 of base into height. So if you know the base and you know the height, you can apply this formula, half b into h. There's one more formula that you did in grade 9, that was Heron's formula. So Heron's formula is area is s into s minus a into s minus b into s minus c, where s is the semi-perimeter and a, b, c are the three sides of a triangle, any triangle. Okay? So this is one more formula for finding area of a triangle, provided all three sides are given. Then one more formula which you have done in grade 10 as for area is concerned, area of circular regions. That means if you have any two sides are given and the angle between those two sides are given, two sides and the included angle, the formula is like this: area is 1/2 of product of those two sides into sine of the included angle. 1/2 product of two sides into sine of the included angle. So these are the three main formulae for finding area of any triangle, whatever triangle you have. But if you have an equilateral triangle, like if I have A, B, C, an equilateral triangle, I take all three sides as A, then area of this triangle would be √3/4 into side square. So this is your formula number 4. That means till date you have been working with these 4 formulae as far area of the triangle is concerned. Now, as for this coordinate geometry is concerned, area of a triangle is being prepared. We find area of a triangle provided you know the vertices. Means you know the coordinates of all the 3 vertices. And same formula gets extended to area of a quadrilateral if you have the vertices. Means if you know the coordinates of all the 4 vertices in case of a quadrilateral. Let me take first the formula for area of a triangle. Now let me take a triangle ABC, and the vertices will take coordinates of A as x1, y1, coordinates of B as x2, y2, coordinates of C as x3, y3. Okay. Now if we are concerned with finding the area of this triangle, area means the region, how much surface has been occupied by this triangle. The formula is like this. Let me write the formula. So area of triangle ABC is, I will be writing the formula, but to write the formula, I would ask you to remember that 1, 2, 3 to be written this way in a cyclic order. So formula is like this: x1 into y2 minus y3, in fact 1/2, x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this formula gives you the area of a triangle whose 3 vertices are given. Now how to retain this formula, how you remember? So you wrote area is 1/2. Most of the area formulae have 1/2 in the beginning. Now x1. So we follow a cyclic order. x1 into y2 minus y3. Then when you take x2, it will be y3 minus y1. And when you take x3, it will be y1 minus y2. So this order is being followed. Now, we haven't been asked to prove this formula. If you have to prove it, you make use of the area. It's already proved. It's not from examination point of view. So we'll take this formula and apply it to the textual sums. Now, you can remember this formula, but there's one other way to retain this formula, and I would like to show you that way. So this is one way. Usually the textbook is using this formula, but I have one more way of expressing the formula. That would be like this. See, we write area of triangle ABC. So what you do, we call it as a column method. You take the coordinates of A, that's x1, y1, coordinates of B, x2, y2, coordinates of C, x3, y3. Then again coordinates of A, x1, y1. Coordinates of A, coordinates of B, coordinates of C, then again coordinates of A. So when you write the formula, you write 1/2 x1 into y2 plus x2 into y3 plus x3 into y1. Okay? Then minus times, now the direction changes, x1 into y3 plus x3 into y2 plus x2 into y1. In fact, this and this, they are same results, but the format is different. So I prefer this format because this will help you when we move on to area of a quadrilateral. So this is one way and this is the other way. Both are same, results are same. So we'll apply this result to exercise 7.1. We're asked to find area of a triangle whose 3 vertices are given. There are 2 parts. I'll be taking one of the parts. So this is exercise 7.1. Exercise 7.3, question number 1. Let me take part 1. My 3 vertices are given as 2, 3. So it's A 2, 3, B minus 1, 0, and C 2, minus 4. So we are asked to find area of a triangle which is formed by these 3 vertices. So what I do, I follow the column method as I said. Let me take coordinates of A, that's 2, 3, 2, 3. Coordinates of B, minus 1, 0. Coordinates of C, 2, minus 4. Then again you write coordinates of A. Now we say area of triangle ABC. That will be 1/2. Result is x1 into y2. This into this. That means 2 into 0 will be 0. This into this. Plus this into this. That is 4. Plus 2 into 3. That is 6. Then we change the order. We change the direction. So that will be minus times 2 into minus 4. That's minus 8 plus 2 into 0. That is 0 plus this into 3. That's minus 3. So be careful about the signs. So that would be area of the triangle. This is 1/2. Let's simplify this. This is simply 10. Okay, minus times, this is simply minus 11. Okay, so that would be 1/2 of 10 plus 11. And that is 21/2. That is 10.5 square units. So area of a triangle that is formed by these 3 vertices A, B, C, whose coordinates are given, that is 10.5 square units. So that was one part. You have second part. You can do it on the same lines. We'll move on to question number 2, which is a little bit different. Different in the sense it says, in each of the following, find the value of k for which the points are collinear. Points are collinear. My dear friends, if you have seen my first video that was based on distance formula, if you have observed, there I mentioned that the question based on collinearity of 3 points, it can be attempted using distance formula, using section formula, as well as using area formula. If you remember, I didn't discuss that question using distance formula because using distance formula working on collinearity of 3 points is cumbersome. You have to apply distance formula thrice. So I had left that sum there. So I will attempt that sum in as far this video is concerned, because collinearity of 3 points is tackled using area formula. Let's see how that's being done. See, if you have 3 points, see, 3 points are there that make a triangle ABC, and 3 points are there, they fall on the same line. Okay. Now, in this situation, A, B, C, 3 points, they are collinear, they fall on the same line. Now, A, B, C, these 3 points are non-collinear. So, a triangle is formed by 3 non-collinear points. So, when 3 points are non-collinear, you get a triangle and it has some area. Its area is non-zero. For this triangle, area is non-zero. But as for collinear points are concerned, if you frame a triangle, we can't frame a triangle using 3 collinear points. But let's take for the point of discussion, okay, triangle is formed. But if a triangle is formed, what will be area of that triangle? So area of that triangle, which is being obtained using 3 collinear points, its area will be 0. So if 3 points are collinear, we say if A, B, and C are collinear, that means they fall on the same line, then area of triangle ABC will be 0. So area of a triangle formed by 3 collinear points is 0, because collinear points they don't frame, they don't make a triangle. So non-collinear points that they make a triangle and its area will be non-zero. So let's try that sum. That was exercise 7.1. We were asked to verify that if these 3 points are collinear. That was your question number 3. I had left that question and I will be doing it using area result. So that's exercise 7.1, question number 3. Determine if these 3 points are collinear. So we'll take that sum. This is my question number 3 of exercise 7.1. What are the 3 points? Points are 1, 5, B, 2, 3, and C, minus 2, minus 11. So you don't have to prove that these 3 points are collinear. You have to determine if these points are collinear. They can be collinear or they can be non-collinear. So whenever question is based on collinearity, I recommend use area formula because that's quite convenient. Now these 3 points are there. So we have to check it out if they are collinear. We say let us assume A, B, and C are collinear. No, we won't assume. Why should we assume? We'll first find the area. Let's find area and find out. So apply the area formula, column method. Coordinates of A, 1, 5. Coordinates of B, 2, 3. Coordinates of C, minus 2, minus 11. And again, coordinates of A. This is row 1, coordinates of A, coordinates of B, row 2, coordinates of C, row 3, and again coordinates of A. So apply the area result. So area of triangle that's formed by these 3 points A, B, and C would be 1/2. 1 into 3, that will be 3. 2 into minus 11, that's minus 22, plus 2 into minus 5, that's minus 10. Minus times, change this direction. 1 into minus 11 is minus 11. Minus 2 into 3, that will be minus 6. 2 into 5, that's plus 10. So we're going to find out what is the area. If area turns out to be 0, points are collinear. Otherwise, they are non-collinear. So let's simplify. This is 1/2. This is 3 minus 33. Minus, this will be minus 17 plus 10. That is minus 7. That's 1/2. This is minus 30 plus 7. This is minus 23 upon 2. So we can ignore the negative sign because area is a quantity. So this is not equal to 0. That means points are not collinear. If area is 0, See, you could ignore the negative sign. This is not turning out to be 0. So since area is not 0, we say points are not collinear. Area found by 3 points is 0, then the points are collinear. So we conclude points A, B, and C are not collinear. They are not collinear means they are non-collinear. Okay. Now, if you had done this result using distance formula, you know what you had to do? You had to find distance between AB, distance between BC, and distance between AC. Then find out if AB, see, I will tell you what you had to do. If this is A, this is B, this is C. If 3 points are collinear, then AB distance plus BC distance is equal to AC distance. See? AB distance plus DC distance should be equal to AC distance. That means using distance formula, you are finding AB length, then BC length, then again AC length. Then just analyze that if AB plus BC is equal to AC. If it works, then the points are collinear. But using area formula, it's quite convenient. It took us less time to evaluate, to find out the area. Area didn't turn out to be 0, so we say points are not collinear. Now we'll go back to our exercise 7.3. And question number 2 says, in each of the following, find the value of k for which the points are collinear. Now points are already given to be collinear and you have to find the value of k. Just remember, if points are collinear, area is 0. If points are not collinear, area is not 0. So there is the value of k which is to be found. For that value, you have to find out what will be the value of k so that the points are collinear. We'll move on to question number 2. Question 2 of exercise 7.3. Let's take part 1. Coordinates of A are 7, minus 2. 7, minus 2. Coordinates of B are 5, 1. And coordinates of C are 3, k. Now, you have to find the value of k. K is the y coordinate of vertex C. What's the value given to k so that these 3 points are collinear? So these 3 points are collinear for a certain value of k. So we'll take area and we will equate area of the triangle ABC equal to 0 because points are collinear, so area of triangle ABC will be 0. So when you equate, you get an equation in terms of k, and solving that you will get the value of k. So area of triangle ABC is given to be 0. Why? Because points are collinear for a certain value of k. Apply the column method. Coordinates of A is 7, minus 2. Coordinates of B 5, 1. Coordinates of C 3, k. Again coordinates of A 7, minus 2. Okay, so let's work on this equation. So area of triangle will be 1/2. This is given because points are collinear. This is given to you. 1/2, bracket starts. This into this. 7 into 1 will be 7 plus 5 into k. That's 5k plus 3 into minus 2. That's minus 6. Bracket closes. Then minus times. Now we change the direction. 7 into k. That's 7k plus 3 into 1, that's 3, plus 5 into minus 2, that's minus 10. Bracket closes, equal to 0. So we have an equation in terms of k. It's a linear equation. So solving this, we get the value of k. Let me multiply both sides by 2 so that this gets cancelled. So I'm left with 5k plus 1. Because 7 minus 6 is 1, minus this is 7k minus 7 equal to 0. Because I multiply both sides by 2, get rid of this 2. Now simplifying, this is 5k plus 1 minus 7k plus 7 equal to 0. So 7 plus 1 makes it 8. 7 and 5k, that would be minus 2k equal to 0. So that gives us 8 equal to 2k, or that means k equal to 4. So if k is being given as 4, these 3 points turn out to be collinear. So for what value of k these 3 points are collinear, we say k has to be 4. When you put k as 4, 3 points turn out to be collinear. You have second part of question number 2, which is on the same line, so that you could work out. Now, I move on to question number 3. And this is based on midpoint formula, and we have done midpoint formula. I will recapitulate that midpoint formula for you. We'll rub this. If you remember the midpoint formula, if we have a line segment AB whose coordinates are given, this is x1, y1, and B has coordinates x2, y2. And C is the midpoint whose coordinates are x, y. The ratio is 1:1, isn't it? Now, last time we discussed that the x coordinate of the midpoint will be the sum of the x coordinates of the endpoints upon 2, and the y coordinate of the midpoint will be the sum of the y coordinates of the endpoints upon 2. So we'll apply this formula to question number 3, because this is based on midpoint. Midpoint formula is to be used. You have a triangle whose vertices are given. Then you take midpoints of all the 3 sides. So you will get 3 midpoints. You join them, you will get one more triangle. So you have 2 triangles in picture. And what you have to find the ratio of the newly formed triangle to the original triangle. What is the ratio? Okay. Now, just remember, the x coordinate of the midpoint. X coordinate of the midpoint is the mean. This is the mean of the x coordinates of the endpoints. And y coordinate of the midpoint is the arithmetic mean, or you call it as average of the y coordinates of the endpoints. Or simple, x is x1 plus x2 by 2, and so on for y. So this is question number 3 of the same exercise. It says find the area of the triangle that is formed by joining the midpoints of the 3 sides of a triangle whose vertices are given. So we have a triangle, big triangle given, whose vertices are given. This is triangle ABC. Its vertices are given. What are the vertices? 0, minus 1. 0, minus 1. Coordinates of A. Coordinates of B, 2, 1. 2, 1. Coordinates of B. And coordinates of C are 0, 3. 0, 3. These are coordinates of A, B, C given. He says find the area of the triangle that's formed by joining the midpoint of all the 3 sides. So we are taking midpoints of these 3 sides. Let me take this as D, this as E, and this as F. So D, E, and F, when you join them, you get a triangle DEF or DFE. DEF or DFE, right? So that means you need to find the coordinates of D as well as E and F. So let's see. Coordinates of D are, see, D will be at the x coordinates of the endpoints divided by 2, comma, the sum of y coordinates of the endpoints divided by 2. That is simply 1, 0. See, the x coordinate is 0 plus 2 by 2, minus 1 plus 1 by 2. That means 1 minus 1 by 2. So this is 1, 0. So coordinates of D you found. Now coordinates of E. RE will be 2 plus 0 by 2, comma, 1 plus 3 upon 2. That is simply 2 by 2 is 1, comma, 3 plus 1, 4, 4 by 2 is 2. So we found coordinates of E. Now we'll find coordinates of F are F. Let's move on to F. That means 0 plus 0 by 2, comma, minus 1 plus 3 by 2. That is, F is 0 plus 0, 0 by 2. 0 by any number is 0, except 0. Mind it. 3 minus 1, 2. 2 by 2 is 1. So we prepare coordinates of D, coordinates of E, and coordinates of F. Now we need to find area of D, E, F, and A, B, C. So you have to apply area formula twice. So I will rub this part. Okay. So D, E, and F are given to me. So let me write the coordinates in front of D, E, and F. F has coordinates 0, 1. E has coordinates 1, 2. So let me write coordinates of C little bit here, 0, 3. And coordinates of E are 1, 2. And coordinates of D are 1, 0. So we have to first find area of triangle DEF as well as area of the main triangle. Then find the ratio of this small triangle to the bigger triangle. So we have to apply area formula twice. Okay. So we'll work out, this is question number 3. So area of triangle ABC. What is that? That's 1/2. Okay. So for that, let's list the coordinates of ABC. A, 0, -1, B, 2, 1, C, 0, 3, again coordinates of A. Don't forget to write coordinates of A once more. Coordinates of A, coordinates of B, coordinates of C, again coordinates of A. So area of triangle ABC will be this into this, plus this into this, plus this into this, then minus times this into this, and so on. So this will be 0 into 1 is 0, plus 2 into 3 is 6, 0 into this is 0, okay, minus times, okay, 0 into 3 is 0, plus 0 into 1 is 0, plus 2 into -1, that's -2. This area of triangle ABC. Let's see what it turns out. This will be 6 minus, this is simply 0, minus plus 6 plus 2. That's 8 by 2. That's 4. SU means square units. So area of the big triangle turned out to be 4 units. Now you have to find area of the smaller triangle, that is DEF. So we write here area of triangle ABC is 4 square units. Okay. Now we will find area of the triangle in the middle, formed in the middle. Now we have to find the area of triangle DEF. For that, list the coordinates. DEF or DFE, whatever you want. DEF, okay. D coordinates 1, 0. E coordinates 1, 2. F coordinates 0, 1. Again, coordinates of the first row. That means coordinates of D. And do keep a distance. Don't just confine these two vertical bars. Keep a distance. Just have convenience for yourself. So I would write area of triangle DEF. That's 1/2. Okay. Coordinates of D, E, F, again coordinates of D. 1 into 2, that is 2. Plus 1 into 1, that's 1. Plus 0 into 0, that's 0. Close the brackets, minus times. 1 into 1 is 1. Plus 0 into 2 is 0. Plus 1 into 0 is 0. So this is 1/2. 2 plus 1 makes it 3 minus 1. Okay? That's 2 by 2. That's 1 unit. So area of triangle DEF is 1 square unit. Okay. Now we are asked, find the ratio of this area to the area of the given triangle. So you have to find area of triangle DEF to area of triangle ABC. That is obviously 1:4. It's quite clear. Small triangle to the big triangle, 1:4. So area of triangle DEF, right here, ratio of area of triangle DEF to area of triangle ABC. That is 1:4. This could be 1:4. You've done a similar question in parallelograms in grade 9th, where you make use of the concept of midpoint theorem. There also you prepare the area. Similar triangle is to be done using similarity. You could work out this sum using congruence as well as similarity. Ratio of this triangle to the original triangle is 1:4. Anyway, so we have been successful in finding area of a triangle whose three vertices are given using the concept of coordinate geometry. Now you can apply the same result to area of a quadrilateral. And for that we have question number 4 given, and there's one more sum again which I had left, that was the last sum of exercise 7.2. This was find the area of a rhombus whose vertices are given. So we'll apply the same formula to area of a quadrilateral. I will rub this. Now we'll move on to finding area of a quadrilateral, and the formula that is mentioned in the textbook is the same formula finding area of a triangle. Then you have to apply the same formula twice, because if you take a quadrilateral ABCD, any quadrilateral ABCD whose vertices are given, if you apply the formula that's mentioned in the textbook, the formula is like this: area of triangle ABC, that's 1/2 x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So what you do with this formula, which we didn't use, we use the same formula but in a different format. Using this formula, you find area of a triangle whose three vertices are given. And if a quadrilateral is given and you are asked to find area of this quadrilateral, what you do, you draw a diagonal so that the triangle quadrilateral gets split into two triangles. Now apply this formula twice, because we will apply this formula to triangle ABC, then to triangle ACD, then sum up. That will give you the area of the quadrilateral. So that means you are using this formula twice. But the method I taught you, the column method, using that method you don't have to find area of these two triangles then sum those two triangles up. No, you find area of the quadrilateral in one go. So we'll be using the same format, the column method, for finding area of a quadrilateral. And if you remember in my second video that was based on section formula, I had left question number 10th of exercise 7.2 because this was based on area, and I had asked you, in fact I had informed you that once we take up area formula, so we'll work out this sum. So I'll be taking that sum, that's question number 10, finding area of a rhombus whose four vertices are given. You have other ways also, finding area of the finding length of the diagonals, then apply area of rhombus 1/2 of D1 into D2. But using area formula, it's quite convenient. So I will take up question 10th of exercise 7.2. This is question 10th, exercise 7.2. A rhombus is given whose vertices are 3, 0, A 3, 0. Coordinates of B are given 4, -5. Coordinates of C are given to be -1, 4. And coordinates of D are given to be -2, -1. Okay. Now find the area of the rhombus. Okay. So A, B, C, D. Use the same concept that we use for a triangle. It's coordinates of A, coordinates of B, coordinates of C, now coordinates of D, coordinates of A. So we'll have coordinates of A 3, 0, coordinates of B 4, 5, C -1, 4, coordinates of D -2, -1, and again coordinates of A 3, 0. Apply the same logic. So area of ABCD, it's a rhombus, same formula, 1/2, 3 into 5, that's 15, plus 4 into 4, that's 16, plus -1 into 1, that's 1, plus -2 into 0, that's simply 0, bracket closes, minus times, 3 into -1, that's -3, -2 into 4, it's -8, -1 into 5, it's -5, 4 into 0, that's 0. So this area of a quadrilateral, in fact, this is a rhombus here. A, B, C, D, again A. Now simplify this. This is 1 half. 15, 1, 16, 16, 16, 32, minus 5, 3, 8, 8, 8, 16, minus 16. 5, 3, 8 and 8, that's minus 16. That's 1 half, 32 plus 16. What's that? That is 48 upon 2. That is 24 square units. SU. So area of this rhombus is 24 square units. Now, as far as this 7.3 exercise is concerned, you have question number 4, which is to be done on the same lines. Vertices are given, be it any quadrilateral, so you apply the same logic, make use of the column method, then find area of the quadrilateral. So I hope you will do this on the same lines. Now we have the last sum of this exercise, that is 7.3. This is question number 5. Let's see what the question says. He says you have studied in class 9th. This was based on triangles. That the median of a triangle divides into two triangles of equal area. Verify the result of triangle ABC whose vertices are given. So a triangle is given whose 3 vertices are given. A median of one of the sides is given, and we know the result says that median divides a triangle into two triangles of equal area. They are not congruent, they are equal in area. So we have to verify that result using the concept of area of coordinate geometry. So I'll be rubbing this. This is last sum of this exercise, question number 5. So what are the vertices? 4, comma, minus 6. Let me take a triangle. 4, comma, minus 6. Coordinates of B are 3, comma, minus 2. Coordinates of C are 5, comma, 2. So we take median of one of the sides. So you take the midpoint. Let me take midpoint of BC, that's D. Join A with D, so AD is the median. So what you have to prove? You have to prove that this median divides this triangle into two triangles of equal area. That means I have to show area of triangle ABC, ABD is same as area of triangle ADC. So we have two triangles in picture, triangle ABD as well as ADC. So we are asked to show that they are equal in area. So for that I will apply area formula to triangle ABD as well as ADC. For that we need to find coordinates of D. What are coordinates of D? So we'll be using the midpoint formula. So what does midpoint formula say? Coordinates of D will be, the x coordinate will be sum of the x coordinates of the endpoints. 3 plus 5, 8, 8 by 2 is 4. Minus 2 plus 2, that's 0, 0 by 2 is 0. So we found coordinates of D. So D has coordinates 4, comma 0. Now let me first find area of triangle ABD using the area formula. So go to the column method. Coordinates of A 4, comma minus 6. Coordinates of B 3, comma minus 2. Coordinates of D 4, comma 0. A, B, D. Again coordinates of A 4, comma minus 6. We have been doing this. So this is area of triangle ABD. It's 1 half. Same logic, 4 into minus 2, that's minus 8, plus 3 into 0, that's 0, plus 4 into minus 6, that's minus 24. Minus times change the direction. This is 4 into 0, that's 0, plus 4 into minus 2, that's minus 8, plus 3 into minus 6, that's minus 18. Okay? So this will be 1 half. 24 into, 24 and 8, that's 32, minus 32. And this is minus times 18 and 8, that's minus 26. So let's simplify. This is 1 half minus 32 plus 26. So that would be minus 6 upon 2, that's minus 3. So area of triangle AB, it should be ABD. Not ABC, it should be ABD, right? ABD. It's minus 3. So since area is a quantity we ignore, so area we ignore the negative sign, or you could take the modulus of this area. So area of triangle ABD turned out to be 3 units. Okay. That means area of triangle ADC should be also 3 units. So let's work out that. Okay. So we got ABD as 3 units. Now we work for ADC. We'll rub this. Okay, now area of triangle, this equal to this, you have to prove this. We are working on this. ABD we calculated, now we move on to ADC. Area of triangle ADC, same formula. So go to the coordinates of A, D and C. Coordinates of A 4, -6. Coordinates of D 4, 0. Coordinates of C 5, 2. Again, coordinates of A 4, -6. A, D, C, again coordinates of A. So formula is 1/2. 4 into 0 is 0. 4 into 2 is 8, plus 8, plus 5 into -6 is -30. Okay. Then minus times 4 into 2 is 8, plus 5 into 0 is 0, minus 4 into 6 is -24. Bracket closes. So this is 1/2. This is 30 minus 30 plus 8, that is -22. So this is minus times. This is 16. -16. So this is -22 plus 16. 1/2. So that would be -6/2. That's also -3. So area of triangle ADC, taking this as quantity, is also 3 square units. So we have derived that median divides a triangle into 2 triangles of equal area. Area of this triangle 1 and triangle 2 is equal. So this brings us to the end of this subtopic, that is area of a triangle as well as area of a quadrilateral. I hope this will help you as for preparing for your board examination. So all the best, happy learning. Thanks.